All right, so this is our kinematics practice problem number 13. It's a super famous problem. Every physics book has it, and it's the monkey and the zookeeper problem. So essentially, they say the zookeeper needs to get food to the monkey who's hanging in a tree, so he's going to shoot an arrow at them or something like that. And they want to know where exactly does the zookeeper need to aim in order to hit the monkey if the monkey lets go at the same point that the arrow is shot, right? So the arrow is going to go out, right, like this, going to follow a parabolic path because it's a projectile, and the monkey is going to end up falling straight down. All right, so again, we want to do we need to aim above? Do we need to aim below? Can we aim straight at the monkey so that the monkey gets the arrow? So really what we're looking for is we need to find out, can the arrow and the monkey get to the same position, X and Y, at the same time period? Because if we can do those three things, then we'll know what we have to do, and we'll know that the arrow gets to the monkey. So the first thing we're going to look at is when the position of the dart is equal to the X position of the monkey. Okay, so when these two things occur, when the position of the dart and the monkey are in the same spot in the X direction, then we know that at least that we're setting it up properly. We're good to go there. So let's find out when the dart, or the X position, and the monkey X position. So to find the X position of the dart, it's going to be a function of its initial speed and how long it takes to get there, right? V equals d over t, and we just rearrange it. So then x is equal to v times t. So then we know that it's going to be equal to v sub o cosine theta times t, or how long it takes to get there. So this is going to tell us, if we want to know wherever the dart is at any time, it's going to be just this equation that tells us. Well, let's also look at the monkey. If we think about the monkey, right, he can only fall straight down. That's all he's doing. He's hanging from a tree and then he lets go. He can only fall straight down. In that case, our X position is always going to be D. No matter what period of time, the X distance away, the horizontal distance away from the hunter or the zookeeper, is always going to be that D position. Okay, so when these two are equal, so when the position of the monkey is equal to the position, the X position of the dart, we get then that D is going to be equal to V sub O cosine theta times T. So when we can find, if we knew what D was and we knew what V sub O and theta was, we could find out that time when they're going to be hit. All right. Well, that time when these two things are equal to each other occurs when we get D equals V sub O cosine theta. All right, so all I did was, again, when these two quantities are in the same X position, so when the dart and the monkey are in the same X position, that same horizontal distance, it needs to be at a time of D over V sub O cosine theta. Okay, so now essentially we have figured out when the x's are going to be equal to each other. All right, so looking at this, we now know that when the position of the dart is equal to the position of the monkey, this is what the time is going to be. All right, and we can plug in the, if we knew the distance that it had to travel in the x direction, we knew the initial speed and the angle, we could find out what that time would be when in the X position, the dart and the monkey are in the same spot. So now we need to look at when is the Y of the dart equal to the Y of the monkey. Okay, and we're going to look at a few different things. So let's start with the monkey. All right, so the Y of the monkey. And we know that it's got this height here. It's going to start at the top of the tree, and when it lets go, it's going to fall. Right? So if we look at what we start with, we'll call it, this height here. Well, this height here, right, it's if we look at the triangle between this triangle, this side, and this length, this height is the opposite side of this triangle that's carved out between this, the distance the arrow is going to travel, or the dart, right, and the distance in the x direction. So if we have the opposite side and we know the adjacent side, right, and this is our angle here, theta, then this side is going to be equal to d tangent theta, right? Because again, this is the opposite side. Right? If we know that tangent theta is equal to y over d, then this y, right, is going to be equal to d times the tangent of theta. So we know that this is the total height, or the maximum height that, or the height that the monkey starts at. Well, as soon as he falls, the height that he has, the y, is going to get smaller and smaller and smaller as he falls down the tree. So what we really need to know, if we're going to find out what his position is, the monkey's position is at any time, we need to know how this distance is going to change. All right? So if we know how much this distance is going to change, and then we know this height, well, the leftover part then is what his actual position is. And we know just from our basic kinematic equations that this distance here, right, if we think about y is equal to y sub o plus v sub o y t plus 1/2 gt squared, right? Well, if he starts right here, your y sub o is 0, right? And your v sub o is 0 because he's at rest, then it's just equal to 1/2 gt squared. So wherever he is here, or the distance that he loses as he falls is equal to 1/2 gt squared. So this height to whatever height he's at is going to be equal to 1/2 gt squared. So if we're going to find out what the height of the monkey is at any part in time, it's going to be this total height that he starts at minus the height that he loses, or the height that he travels as he falls. So it's going to be equal to d tangent theta, which is again the height that he starts at, minus 1/2 gt squared. And this is the height that he falls when he lets go. And we can find out again that position by knowing what time he's going to be in there. Okay? So now let's look at the y of the dart, or the arrow. And that just very simply follows our kinematic equation of y sub o plus v sub o y t plus 1/2 gt squared. Okay? Now y sub o is going to be 0. We'll take the origin of the dart to be right at the bottom. And what we're going to do, we're going to do a quick little thing here. So y sub o, right, y of the dart is going to be equal to v sub o y. Well, v sub o y is now the y component of the speed. So it's v sub o times the sine of theta, right? And then we've got t. And then I'm going to make this a minus 1/2 gt squared. What I've really done is, we know that g is -10. So all I've done is I've pulled the negative sign out of the g to make this minus. So now instead of being 1 plus 1/2 -10 t squared, it's now minus 1/2 10t squared. Okay? So these are the two situations that we have. This is going to be the height of the monkey, and we can find it by how he falls. And this is going to be the height of the arrow or the dart, and that's also a function of time. Now remember, if we want to know, can the monkey and the dart be at the same x and the same y at the same time, because that's what has to happen if they're going to hit. They have to be in the same place at the same time. Then we need to look at, when is the y of the monkey equal to the y of the dart? And in that case, all I'm going to do is plug in this stuff that I have here. So we have d tangent theta is equal, minus 1/2 gt squared is equal to v sub o sine theta t minus 1/2 gt squared. And the nice thing we see is that the 1/2 gt squareds cancel out. Okay, so in this case, we know then that d tangent theta is equal to v sub o sine theta t. All right, that's lovely, but we need to, all right, so this will tell us when the two are at the same y position. All right, well, we know that they'll be at the same x position when this is our t. Right? So when our time is equal to this, we know that they're at the same x position. So if we plug this time into this t right here, and if these two sides are equal, they're the same, then we know that they're also at the same y position. Okay, again, we know that when the monkey and the dart are at the same horizontal position, time is equal to d over v cosine theta t. So at this time, if we plug it in here, when we plug it in here, we're saying that they have the same x position, and then if we plug the time in, if they're also at the same y position, these two sides should be equal to each other. So that's what we're going to do now. All right, so we get d tangent theta is equal to v sub o sine theta, and then for t, it's d v sub o cosine theta. And very quickly, the v's cancel out, okay? And knowing a little bit about our trig identities, we know that sine over cosine is tangent right here. So what we're saying, and we see that they're the same, what this is saying then is that when x and t are equal to each other, this is the time. And when this time occurs, they're also at the same height. So it's completely possible, or it is possible, it does happen, physics shows that when you aim directly at the monkey and you let go at the same time that the monkey lets go, they will be at the same x position, the same y position, and at the same time. So the answer then is, don't aim above the monkey, don't aim below the monkey, aim directly at the monkey, and you'll hit him. Okay? And what this is also saying is that the amount that the arrow falls is equal to the amount that the monkey falls as they are both released. Another way you can think of this is if you remove the g term, right? So there's no gravity. When you shoot the arrow out, it's going to go straight at the monkey. It's going to go straight, right? Nothing is causing it to fall. Well, the monkey, when the monkey lets go of the tree, there's no g, so he just hangs out, kind of weird, just hovering around. So again, aim straight at the monkey, you'll hit him. And I know it's a lot of math, but again, it shows that when the x horizontal positions of the x are the same, we get this to be the time. So when we plug that time into the y, we show that they are also at the same y position. Right? So then, if we're talking about number 13, right, we know then that, or the answer should be option C, right? He should aim all at the monkey. And that is problem number 13, and also the famous monkey and zookeeper problem.